in this example, we want to graph f of x equals cubed root of x plus 2 minus 1. So here you want to resist the temptations to go right into plotting points, right? You definitely want to move away from that method. The reason why is by the time you get to trig and calculus, you need to be able to graph things by doing these translations. So we're kind of preparing, especially for trigonometry. It's really hard to plot. You can't just plot points to get these trigonometric graphs that have shifted around the plane. So we're essentially preparing for trigonometry here. So we'll start with our base graph here. So that'll just be f of x equals cubed root of x, right? And that was in the previous video, but this is something you should at least work to have internalized, right? So let's see, that graph goes like this. It has kind of has this weird S-looking thing, and it goes up through 8, 8, 2, and then negative 8, negative 2, and goes up through negative 1, 0, and then 1, like this. So let's connect these dots and see what that cubed root graph looks like. Something like that. And now you want to think of these points that we've plotted like little handles, right? And you can pick those up, and we want to do our translations here. So plus 2 inside the radical is 2 to the left. It's the opposite. When it's inside the radical, it's the opposite direction. So this says plus, so horizontal shifts essentially go the opposite direction of the sign here, so it's going to be 2 to the left. And then our vertical shifts, they essentially match the sign here, so it's going to be 1 down. So basically we're taking all these fixed points that we have here and treat them like little handles and move them 2 to the left and 1 down. So here, this 1 down here, I'm going to move 2 to the left and 1 down. 2 to the left and 1 down for this negative 1, 1. Here's the 0, 0, 2 to the left and 1 down. Here's our 1, 1, 2 to the left and 1 down. And our 8, 2, 2 to the left and 1 down. This one, this red one right here wasn't actually a point. Okay, there we go. So let's connect these dots and see what our new graph looks like. There we go. It's the same shaped graph, just moved 2 units to the left and 1 down, right? So use those translations. Don't go in. It's not just because it's not really good practice. It's also because when I go to grade an exam, anytime someone tries to use a table to graph graphs like this, it's almost always wrong. It's not wrong because the table is wrong. You know, if someone uses a table and graphs it perfectly, I usually give them credit, but it's almost always a sign that someone doesn't know what they're doing, and they try to use it and their graph turns out something that looks nothing like the intended graph. So it's just, it's a bad practice, right? Get into the habit of using these transformations. It's a much more elegant way to graph, and it's going to serve us very well when we get to trigonometry.